All right, derivative of x to the x. It's not the same thing as x squared, which is a power rule where you would just do 2 to the x, move the 2, and decrease the 2 by 1. No, this is not it. So, in the case when we have a function in terms of x to the power of another function in terms of x, so in this case we have the first function in terms of x to the power of another function in terms of x, we typically want to use something called logarithmic differentiation. Okay, so this is what we're going to use for the tool we're going to use. Okay, so how does that work? Using, so we're going to take the ln on both sides. This is the step 1. Ln y is equal to ln x to the x. That allows us to use the logarithmic rules to move the x over, which is going to be a form that we can digest now. We can do something with this. And so now we left with ln y is equal to x times ln x. What now? Well, since we can do something on each side, as long as we do it on both sides equally, then we can take the derivative on both sides. d dx of ln y is equal to d dx of x ln x. All right. And we're getting closer. So this leaves us with d dx ln y on the left side become 1 over y, but we have to use the chain rule in this case because y is a function in terms of x's. So using the chain rule times y prime, and that's equal to, so the derivative of the function x times ln x, so it's like we have first function we can call u and the second function we can call v, and this leads to the product rule, which we can remember with u prime times v plus u times v prime. So u prime is 1 times ln x plus, we leave the u alone, so we leave the x alone, times the derivative of v prime, or v prime, which is 1 over x. Okay, so now we're left with 1 over y times 1 y prime is equal to ln x plus 1. Okay, 2 more steps. So let's multiply both sides by y. So we're left with y prime is equal to ln x plus 1 times y. Finally, what is y? Well, y is x to the x. So to clean it up, we go y prime equal ln x plus 1. And we substitute here, we get x to the x. And that's our answer.